And now in this lecture we'll find out the area of a circle. In the drawing we have a semicircle. This is a semicircle. Inside this semicircle we have a circle. And our mission is to find out the area of this circle. In addition, you know that line segment AQ equals to 2 units in its length, line segment TB equals to 8 units in its length. This is angle PQA, that is the right angle, and this angle is angle STB, that is also equals to 90 degrees in size. I repeat again, our mission is to find out the area of this circle that is inside the big semicircle. So first of all, we will define the relevant points to this question with letters. We will define the center of this small circle. This point is point K. Likewise, we will define the center of this big semicircle. This point is point H. We will define the point of tendency of tangent AB with this small circle. This point is point M. And we will define the point of tendency of tangent ST with this small circle. This point is point J. And finally, we define the point of tendency of tangent PQ with this small circle. This point is point Y. AB is the diameter of this semicircle. So AB is a diameter, it is absolutely a straight line. So if we focus on the upper side of this straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3, that the sum of the angles, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle, that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, we will continue to focus on the upper side of the straight line AB at point T. Here the sum of the angles must be equal to 180 degrees according to the same rule 3. So which angles we have at the upper side of AB at point T? We have this angle, that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be also equal to 90 degrees in its size. We will define the radius of this small circle as x, and we will join points K and M together by a straight line. Point K is the center of this circle, point M is the point of the circle itself, therefore Km is the radius of this circle, that is equal to x according to our definition. Here we can implement rule 1, and keep quickly on rule 1. According to rule 1, the tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the drawing you have a circle, and this is tangent AB. It is tangent to this circle at this point, point M. Point M is the point of tendency of tangent AB with this circle. And we have the radius OM is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent, whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule 1. So we can actually implement rule 1 in our drawing. Once in our drawing, we have the radius Km, that is 1 to point M, that is the point of tendency of tangent AB with this small circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MK. If AB is perpendicular to MK, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points K and J together by a straight line. Kj is of course the radius of this circle that is equal to x. Again, we have the radius Kj that is drawn to point J, that is the point of tendency of tangent ST with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent ST will be perpendicular to the radius SK according to rule 1. If ST is perpendicular to Kj, if ST is perpendicular to JK, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So actually, we can do the quadrilateral KJTM. This is quadrilateral KJTM. Inside quadrilateral KJTM, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral KJTM we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be at least a rectangle, not a square. So we relate to this quadrilateral KJTM as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So rectangle KJTM, side KJ must be equal to the opposite side MT. But KJ is x, therefore MT must be also equal to x. Likewise, according to the same rule, in the same rectangle KJTM, side KM must be equal to the opposite side JT, but KM is x, therefore JT must be also equal to x. So actually found out that quadrilateral KJTM is not a rectangle but a square, because all of its sides are equal to each other, each side is equal to x. So I write it down. We found out that quadrilateral KJMT is a square. Likewise, we join points K and Y together by a straight line. KY, line segment KY is of course the radius of this circle that is equal to x according to our definition. Again, we have the radius Ky that is 1 to point Y, that is the point of tendency of tangent PQ with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius YK. If PQ is perpendicular to YK, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So inside quadrilateral YKMQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total it must be equal to 360 degrees. The fourth missing angle must be equal to 90 degrees in size. So here we have a quadrilateral with 4 right angles. Therefore, according to rule 6, it must be this rectangle if not a square. So we relate to this quadrilateral YKMQ as a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So rectangle YKMQ, side YK must be equal to the opposite side QM. But YK is X, therefore QM must be also equal to X. Likewise, according to the sum rule, in the sum rectangle YKMQ, side KM must be equal to the opposite side YQ. But KM is X, therefore YQ is also X. So actually found out that YK MQ is not a rectangle but a square because of the all of its sides are equal to each other. So write it down, quadrilateral YKQM is a square. Actually we found out that line segment or angle, this is angle YKJ. Angle YKJ equals to 90 degrees plus 90 degrees, it is 180 degrees. Any angle is equal to 180 degrees in its size, it is defined as a straight line. So YKJ is a straight line. If YKJ is a straight line, it means that YJ is a straight line. So, but YJ is a straight line that touches the circle at 2 points, Y and J. And any straight line that touches the circle at 2 points is defined as a chord. So YJ is a chord that passes through point K, that is the center of the circle, and you know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, YJ is the diameter of the circle. So I write it down. YJ is the diameter of the circle. And the diameter of YJ equals to X plus X, that is 2X. Anyway, we found out that YJ as a diameter, of course, is a straight line. And therefore, shape YJTQ is a quadrilateral because it has 4 sides. 1, 2, 3, 4. So, we have quadrilateral YJTQ that has 4 right angles. And therefore, we relate to quadrilateral YJTQ as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So, in rectangle YJTQ, side YJ must be equal to the opposite side QT. But YJ equals to 2X, this is the radius of this circle is equal to X, therefore QT must be also equal to 2X. So, I write it down. We actually found out that the length of line segment QT is 2X. In the next step, we have in the drawing an internal match between this big semicircle and this small circle. That is to say, they are touching each other internally at this point. This is their touching point. Whenever we have an internal match between two circles, you can implement rule 9. I'll repeat quickly on rule 9. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. Here we have two circles that touch each other internally at point P. The center of this big circle is there at point O. The center of this small circle is there at point M. The straight line that connects the centers together is, of course, the straight line OM. And this straight line OM, according to this rule 9, must pass through point P, that is their touching point. OMP is one straight line. Again, OMP is one straight line. So can actually implement all 9 in our drawing. Also in our drawing, we have an internal notch between the big semicircle and this small circle. This is to say they are touching each other internally at this point. And therefore, according to rule 9, the straight line that connects their centers together, the center of the big semicircle is at point H. The center of this small circle is at point K. And the straight line that connects the centers together is of course the straight line HK. So the straight line HK must pass through their touching point. This is their touching point. So I will join the centers and K together by straight line. And you can see in the drawing that the straight line HK indeed passes for their touching point. This is their touching point. So we define the touching point as Z. So you can definitely see that the straight line HK passes through point Z, or HKZ is one straight line. What is the definition of line segment KZ? Line segment KZ starts from the center of the circle and ends at point Z, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore KZ is the radius of this circle, that is equal to X. What is the definition of line segment HZ? Line segment HZ starts from point H, that is the center of the semicircle, and ends at point Z, that is the point of the semicircle itself. So this is exactly the definition of a radius. Therefore HZ is the radius of the semicircle. So what is the radius of the semicircle? Actually, the radius of the semicircle equals to the diameter AB over 2. Again, the radius of the semicircle equals to the diameter AB over 2. So write it down. The radius of the semicircle equals to the length of the diameter that is AB over 2. What is the length of AB? The diameter AB of the semicircle in total equals to 2 plus 8, that is 10, plus 2x. Again, AB in total equals to 10 plus 2x. So AB is 10 plus 2x, and if you divide it by 2, you get the diameter of the semicircle. So the diameter is 10 over 2, that is 5, plus 2x over 2, that is x. So in total, we found out that the radius of this semicircle equals to 5 plus x. So we define the radius of this semicircle as capital R, and capital R equals to 5 plus x units in its length. Okay? So, what is the length of this missing side K edge? From the drawing, it is very easy to see that K edge equals to Z edge minus ZK. Again, Z edge minus ZK equals to K edge. So I write it down. The missing side K edge equals to Z edge minus K edge. So the missing side K edge equals to Z edge. Z edge is of course the diameter of the semicircle that is equal to x plus 5 minus kz. Kz equals to x, it is the radius of the small circle. So it is minus x. So in total, the missing side kh equals to x plus 5 minus x. X minus x is 0, so we left only with 5. So the missing side kh equals to 5 units in its length. So this is the missing side kh that is equals to 5 units in its length. So what is the length of line segment MH? This is the line segment, actually, what is the length of this line segment MH? From the drawing, it is very easy to see that MH in total equals to AH, that is the diameter of the semicircle, minus AQ minus QM. Again, AH minus AQ minus QM equals exactly to MH. So I write it down. The missing side MH here equals to AH, that is the diameter of the semicircle, that is AH, that is the radius of the semicircle here, and from the radius of the semicircle we subtract AQ, line segment AQ, and also we subtract this line segment QM. So MH in total equals to AH. AH is the radius of the semicircle, that is equal to x plus 5, minus AQ. AQ equals to 2, so it is minus 2, minus QM. QM equals to x. So in total, the missing side MH equals to, here we have x minus x is 0, and 5 minus 2 is 3. So in total, we can find out that the missing side MH equals to 3 units in its length. This is the missing side MH, that is equals to 3 units in its length. So in the next step, I'll copy the right ring triangle MKH in a new page, and we will implement the Pythagoras theorem on this right triangle MKH in order to find out the missing side KM, that is the radius of this small circle. And after we find the radius, find out the area, it will be very easy because the area of a circle is pi times the radius squared. So I copy the right green triangle KHM in a new page, and we will implement the Pythagoras theorem on this right green triangle KMH. Okay. Here by PT is the operation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. We just try to find out that side MH of the green triangle equals to 3. Side KM is the missing side, that is the radius of the circle, that is equal to x. And the hypotenuse KH equals to 5 units in its length. So actually, this is the right triangle KMH that occurs from the original drawing. According to the Pythagoras theorem, this right triangle KHM, KH square, that is the square of the hypotenuse, equals to KM square plus MH square. Again, KH square equals to KM square plus MH square. So I write it down. The square of the hypotenuse is KH square, and KH square equals to KM square plus MH square. The hypotenuse kh equals to 5, therefore kh squared is 5 squared, that is 25. And it is equal to km squared. Km is x, therefore km squared is x squared plus mh squared. Mh is 3, therefore mh squared is 3 squared, that is 9. So actually found out that one is the Pythagoras theorem, 25 equals to x squared plus 9. Here we subtract 9 from this equation, and we get that x squared equals to 25 minus 9 is 16. We take out of this equation, and we get that the radius of the small circle x equals to the square root of 16, that is 4. Our mission is to find out the area of the small circle. The area of any circle equals to pi times the radius squared. Pi times the radius squared. So it is pi and the radius is x, therefore the radius squared is x squared. So it is pi x squared. X squared is 16, so we substitute x squared by 16. And we get that the radius of the circle equals to pi times 16, or 16 pi square units. Or in terms of numbers, it is equal to 50.265 square units. Repeat again, I actually found out that the area of this small circle is equal to either 16 pi square units, or in terms of numbers, it is equal to 50.265 square units. Okay, so in the next step, I will summarize the lecture. Our mission in this lecture was to find out the area of this circle that is located inside the big semicircle. In addition, we know that line segment AQ equals to 2 units in its length, line segment TB equals to 8 units in its length. This is angle PQA, that is a right angle, and this is angle STB, that is also a right angle. Again, our mission is to find out the area of this circle. So, first of all, AB is the diameter of the semicircle, therefore AB is the diameter, it is absolutely a straight line. So if you focus on the upper side of the straight line AB, it's point Q, here the sum of the angles must be equal to 180 degrees, according to rule 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of A and B, it's point Q. We have this angle that is the right angle plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, we focus on the upper side of the straight line AB at point T. Here, the sum of the angles must be also equal to 180 degrees according to rule 3. So, which angles we have at the upper side of AB at point T? We have this angle that is the right angle plus this missing angle. In total, they must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Then we find the relevant points to these questions with letters. We define the center of this circle as K. We define the center of the big semicircle, this point as point H. We define the point of tendency of tangent PQ with this circle, this point as point Y. We define the point of tendency of tangent AB with this circle, this point as point M. We define the point of tendency of tangent ST with this circle, this point as point J. Then we join points K and M together by straight line. Km is the radius of this circle, and we have the radius Km that is known to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius MK. So if AB is perpendicular to MK, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points K and J together by straight line. Kj is the radius of the circle that is equal to x according to our definition. The radius Kj is on to point J. Therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, We join points k and j together, one straight line. Kj is the radius of this circle that is equal to x. The radius kj is 1 to point y. And therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule 1. So inside quadrilateral y, q, m, k, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this fourth missing angle must be equal to 90 degrees in its size. So inside quadrilateral KYQM, we have 4 right angles. And according to rule 6, any quadrilateral that has 4 right angles must be this right angle if not a square. So in relation to this quadrilateral KYQM is a right angle, but we know that the opposite sides of right angle are equal to each other. So right angle KYQM, side ky must be equal to the opposite side mq. But ky is x, therefore mq must be also equal to x. Likewise, the opposite side km must be equal to side km must be equal to the opposite side yq, according to the sum rule. But km is x, therefore yq must be also equal to x. So actually found out that quadrilateral ykmq is not a rectangle but a square because all of its sides are equal to each other. Likewise, we have this quadrilateral KJTM. Inside this quadrilateral KJTM, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, and again, 270 degrees plus the size of this fourth missing angle must be totally must be equal to 360 degrees. Therefore, the fourth missing angle must be equal to 90 degrees in size. And therefore, can relate to this quadrilateral rectangle, we know that the opposite sides of the rectangle are equal to each other. So rectangle KJTM, side KJ must be equal to the opposite side MT. But KJ is x, therefore MT must be also equal to x. According to the symbol in the sum rectangle KJTM, side KM must be equal to the opposite side JT. But KM is x, therefore JT must be also equal to x. Again, we actually found out that quadrilateral KJTM is not a rectangle but a square, because of the fact that all of its sides are equal to each other. Anyway, we found out here that we have angle YKJ. This is angle YKJ. This is equal to 90 degrees plus 90 degrees, that is 180 degrees. And any angle that is equal to 180 degrees in size must be a straight line. Therefore, YKJ is a straight line. If YKJ is a straight line, it means that YJ is also a straight line. But YJ is a straight line that touches the circle at 2 points Y and J. Therefore, YJ is a chord. YJ is a chord that passes from point K, that is the center of the circle. And we know that any chord that passes from the center of the circle must be defined as a diameter. It is a diameter. So Yj is the diameter of the circle, Yj is the diameter of the circle. So we actually found out that this shape YJTQ has 4 sides. 1, 2, 3, 4. Because Yj is one straight line. Therefore, inside quadrilateral YJTQ we have 4 right angles. Therefore, can relate to this quadrilateral YJTQ as a rectangle. And we also know that the opposite sides of the rectangle are equal to each other. So a rectangle YJTQ side YJ must be equal to the opposite side TQ. But YJ is the diameter of the circle, that is 2x. Therefore, QT also must be equal to 2x. Okay. So here we can implement rule 9 because we have an internal length between this small circle and the big semicircle. That is to say, they are touching each other internally at point Z. And whenever we have an internal length between 2 circles, we can implement rule 9. Repeat rule 9. According to rule 9, if 2 circles touch each other internally, then the straight line that connects their centers together must pass through their touching point. We have those 2 circles that touch each other internally here at point P. The center of the big circle is here at point O. The center of this small circle is here at point M. in the straight line that connects the centers together is of course the straight line OM, and according to this rule 9, the straight line OM must pass from point P, that is the tangent point. Or OMP is one straight line. Again, OMP is one straight line. We can actually implement rule 9 in our drawing. Why? Because in our drawing we have an internal between the semicircle and this small circle, that is to say they are touching each other internally at point Z. Therefore, we know that the center of the big semicircle is there at point H. The center of this small circle is there at point K. And the straight line that connects the centers together, that is the straight line HK, of course. This straight line HK must pass from point Z. Or HKZ is one straight line according to rule 9. Again, HKZ is one straight line. If HKZ is one straight line, it means that HZ is also a straight line. What is the definition of HZ? Point H is the center of the semicircle, point Z is the point of the semicircle itself, therefore HZ is the radius of this semicircle. But what is the radius of the semicircle? Actually, the radius of this semicircle must be equal to the diameter over 2. Again, the radius of this semicircle equals to the diameter over 2. The diameter is AB, therefore AB over 2 is the radius of this semicircle. What is the value of AB over 2? AB, side AB in total equals to 2 plus 8, that is 10 plus 2x. Again, in total AB equals to 10 plus 2x. And if you divide the diameter AB by 2, you get the radius. So the radius is AB over 2, AB is 10 plus 2x over 2. If you divide it by 2, we get the radius. So the radius will be equal to 10 over 2, that is 5, plus 2x over x, that is x. So in total, we found out that the radius capital R of this big semicircle equals to x plus 5. Therefore, the radius at Z of this semicircle, the radius at Z equals to x plus 5. And what is the definition of Kz? Kz is the radius of this small circle, equal to x. So in total, the missing side Kh must be equal to Kz minus Zk. Again, Kh equals to Hz minus Zk. Again, repeat again. Here we have Kh equals to Hz minus Kh. The missing side Kh equals to Hz. Hz is the radius of the semicircle, that is equal to x plus 5 minus Zk. Zk is x. So in total, the missing side Kh equals to x plus 5 minus x. X plus 5 minus x is 5. So we found out that the missing side Kh equals to 5 units in its length. Then we actually found out the missing side MH here. What is the length of this missing side MH? From the drawing, it is very easy to see that MH in total equals to AH, that is the radius of the semicircle, and the radius of the semicircle, that is AH minus AQ minus QM equals to MH. Again, the missing side MH equals to the radius AH minus line segment AQ minus line segment QM. The radius AH equals to x minus 5. Line segment AQ equals to 2 units, and QM is x. So in total, MH equals to x plus 5 minus 2 minus x. X minus x is 0, and 5 minus 2 is 3. So in total, we actually found out that the missing side MH equals to 3 units in its length. In the next step, I copied the right green triangle KMH in a new page and implemented the Pythagoras theorem of this green right triangle KMH. This is the green right triangle KMH that I copied from the original drawing. We already found out that Km is the radius of the small circle, that is x. Therefore, Kh is 5. And we just right now found out that the missing side MH equals to 3 units in its length. According to the Pythagoras theorem, this right triangle KMH, Kh square equals to Km square plus Mh square. Again, Kh square, that is the square of the hypotenuse, must be equal to Km square plus Mh square. Again, Kh square equals to Km square plus Mh square. Kh is 5, therefore Kh square is 5 square, that is 25. and it's equal to km square. Km is x, therefore km square is x square plus mh square. Mh is 3, therefore mh square is 3 squared, that is 9. So in total we found out that 25 equals to x square plus 9. Here we subtract 9 from this equation and finally found out that x square equals to 25 minus 9 is 16. So x square equals to 16. We took out all of this equation and finally found out that x, that is the radius of the circle, equals to the square root of 16, that is 4. And the area of any circle equals to pi times the radius square. Therefore, the area of this circle must be equal to pi times the radius of this circle squared. And we find the radius as x, therefore the radius square is x squared. So the radius of our circle is pi x squared. But x squared is 16, so we solve x squared by 16. Therefore, in total, we found out that the area of this small circle equals to either 16 pi square units, or in terms of numbers, it is equals to 50.265 square units. Okay, thank you very much.